Hi. Welcome to our video, where you will learn how to model in Consteel. This tutorial will focus on fundamental modeling steps and the definition of structural elements. Consteel was designed to enhance engineers' comprehension of real structural behavior and uses special 7 degree of freedom beam elements. Therefore, building a precise model is essential for accurate analysis and design. So let's begin. Let's create a new model. The structure we are going to model is a simple haunched frame. We will use the default recommended standard for this project. Within Consteel, we can build the structure from real structural elements. All functionalities associated with the structural modeling are accessible in the Structural Members tab. First, navigate to the Structural Members tab and click on the Section Administration function to import sections from the section library. We will choose IP 500 sections for the beam and HEB 400 for the columns. Material settings for these sections can be set here as well. Click the Load button to import sections from the library, enabling their use in our structure. Now let's place 2 columns by selecting the column element, choosing the right cross-section, and placing them by clicking the left mouse button. The columns will stand at a height of 6,000 millimeters. Then choose the beam element and modify the section parameter accordingly. Connect the columns with the beam by clicking the left mouse button. Now we just need to adjust the beam's geometry to create a sloping roof structure. To do this, switch to the Geometry tab and select the Refract Selected Line Elements function. Consteel offers built-in guidance on function usage. Initially, select the line at the desired refract point. We will elevate the roof by 1500 millimeters, so we will have to set the insert point at that value. We can use the hotkey for the Z-axis for this, so just press Z on your keyboard, don't move your mouse, and type the 1500 value in to achieve the desired roof height. Let's now create haunches, each spanning 3000 millimeters. Additional parameters in millimeters are the following: the start height will be 600, the end height will be 20, the web thickness will be 10, the flange width will be 200, and the flange thickness will be 16. The position type should be set to lower. Now select the start point of the haunch and then its direction at both frame corners. Now we have to provide structural support for the frame. Select the point support object. As previously mentioned, in Consteel, the finite element for the steel beams and columns has 7 degrees of freedom. Therefore, the point support also features 7 degrees of freedom, with the 7th representing the warping of the cross-section. Accordingly, if a beam end is deemed fixed for warping, like for instance in the case of a thick end plate connection, the 7th degree of freedom should be fixed as well. First, we will support the columns at the foundation. In Consteel, always the 3-dimensional spatial structural behavior is calculated, so in this frame, both the in-plane and out-of-plane behavior should be considered when creating the support system. Accordingly, the next step is to install point supports in the Y direction onto the beam to simulate the effects of the bracing system, controlling the out-of-plane displacements and buckling modes of the members. Placing supports into specific points of the structure can be hard sometimes, but adjusted snapping point distribution can help in accurate object placement. Snapping points are represented with red dots on a structural object. You can adjust snapping point distribution settings at the bottom left according to your preferences. Options include setting the n value to divide a structural element into equal length sections and the d value to divide a structural element into sections of exact length. Additionally, if we consider the purlins attached to the top flange of the beams as effective out-of-plane bracings, we should configure the local eccentricity type to top middle 4 beam supports. It's important to note that when placing a point support with eccentricities on the intersection of overlapping elements, you need to click on the element for which we interpret the support element. We are almost done with modeling the structure. However, for the accurate calculation of the out-of-plane displacements and buckling modes of such frames, the special mechanical behavior of the frame corner zone should be considered. The main mechanical background is that these, generally stiffened, corner zones have usually significantly different behavior than the connected beam member, influenced dominantly by shear effects due to their short length. Connected members, in contrast, demonstrate beam column behavior with a dominant bending effect. The specific behavior of this corner zone and accordingly the out-of-plane behavior of the connected beam and column are dominantly influenced by the configuration of the stiffeners. Consteel has the frame corner wizard function, which is an optional tool for realistic modeling and calculation of corner regions with different stiffeners in structural models. The function automatically identifies corner zones and applies special treatment for geometrical modeling, buckling analysis, plastic analysis, and global checks. It is important to note that special frame corners only be placed on model portions, so we will learn how to create custom portions as well in this tutorial. So first select the whole structure and click on the New Portion function at the top right to create a new one, and name it Frame. With custom portions, you can also manage complicated models into parts to enhance your workflow. Now turn on frame corner recognition, so frame corner definition can be started. Select the created portion, the checkbox, and its name as well, then apply the box type stiffened bolted or welded joint corner type. This action places a constraint element between neighboring elements, resulting in displacements with an opposite sign of the 7th degree of freedom of their nodes at the boundary of corner zones. The element's color always indicates the type of the corner, in our case, it's yellow. As a final step, we should preserve this state for later use. In Consteel, you can create, view, download, edit, and restore previous versions of your models with the history function. An online connection is required to use this function as it only works with cloud-saved models. The purpose of the history function is to preserve different states of a model that can be important for future modifications or model review. However, don't forget to save your model regularly, as creating a model version and saving to the cloud is not the same. Users have the option to assign a name to the history item and append a description to the version if deemed necessary. The name of the model won't change, remains unchanged, regardless of the history version. To create an additional version, simply select the Create History Item button. The latest model version will be always at the top of the timeline. So that was our guide for modeling in Consteel. Thanks for watching. Click the like button if you would like to watch more similar videos, and don't forget to subscribe.